Resource management. I think this is going to be one of the more exciting modules that we have in the course because it touches most of the enterprise class features that vSphere has to offer. So we're going to kickstart this module by talking about resource pools and how they can be used and where you can use them. Then we're going to move on to probably the most sought out feature in a virtual infrastructure, vMotion. And then from there we're going to take a look at the distributed resource scheduler, which also includes distributed power management, enhanced vMotion compatibility, and we'll move on to storage vMotion, which is vMotion's sister-in-law kind of, that allows you to move the files of a running virtual machine. And then we'll wrap up the module by talking about thin provisioning. So let's go ahead and get started. Let's tackle resource pools first. Let's bring up a whiteboard here, a clean whiteboard, so we can talk about this in more detail. So what's a resource pool? A resource pool allows you to divvy up the host's resources the way you as the administrator see most fit for your organization. So you have, like, let's say two CPUs in this ESX host that are 4 gig, and then you have a gig of RAM. So these are resources. A resource pool is the combination of all of these resources and the way you divvy them up or the way you carve them up, so in order to give resources to virtual machines and additional child resource pools. So let's try to make this a little clearer. Let's draw a circle here, and let's assume this is our resource pool. So I'm gonna say resource pool. So let's break this down into two here. Let's carve it up down into two. Let's assume the right side is production and the left side is test and development, whatever you want to call it. So this is our ESX resource pool, and the resource pool here, let's assume, is made up of a 4 gigahertz CPU, which translates into 4000 megahertz, and let's assume we have 1 gig of memory, which translates into 1024 megabytes. So our resource pool, what we have to divvy up is 4000 megahertz and 1024 megabyte of RAM here. This is our resource pool. Now what we've done here is we've carved up the resource pool into two. So we're giving equal amounts to the production environment and to the test environment. And here you will have virtual machines under the production environment, and you will have test machines under the production environment, and they will share those resources on a 50-50 basis. However, let's assume that as your environment grows bigger and as you see necessary that you reorganize the way your resource pool is configured and the way your resources are divvied up, you decide that you've given too much resources to the test environment and you want to give more to the production environment, for example. So let's do this. Let's give our production environment a bigger chunk of this pie. So let's assume you're giving, for example, your production environment here 85% and your test environment 15%. So far we've been dealing with one resource pool that has two child resource pools in it, one for production, one for testing, and the ratio has been 85% for production, 15% for testing. Now let's say within your production environment you have the accounting department that is responsible for a bigger budget of this virtual infrastructure, and you want to make sure you allocate a bigger chunk of the resources for the ESX hosts to the accounting department. So what you do is you create another child resource pool under prod dedicated to the accounting department virtual machines. Let's say this is accounting department. Now all the virtual machines that will be under the accounting department's resource pool are going to get a bigger chunk of the resources, of the physical resources of this ESX host. And as such, you can always carve up more of the production environment, for example, for other departments, marketing, shipping, depending on what kind of departments you have in your organization, making sure that every department gets a fair share of the physical resources based on the amount of contributions or the amount of influence that it has in the IT department, or the amount of importance that it has to the business in general, because what it boils down to here in the end is making sure the company is profitable and we're giving them the services they need to generate money. And you can do child resource pools under the test environment as well. I just chose the production environment here because it makes more sense to carve up child pools for production environments such as the accounting department, marketing department, etc., etc. Now, as we're going to see a little later on when we launch the VI client and we log in to do some of this stuff, you're going to notice that resource pools are objects that are in the inventory. And if they're objects of the inventory, then we can assign access control, security, and permissions to them and to any child object that's created underneath them as well. So now that we've logged into Virtual Center, let's go ahead and create a resource pool. I'm going to right click on the Data Center Lab here, and we're going to drag down to where it says New Resource Pool, and we're going to name this Accounting. So this will be the accounting resource pool where we group all the virtual machines that are accounting related. And let's talk about CPU resources. Now, the first thing we're going to look at is shares. Now, what shares are is the amount of time that this resource pool is going to have as far as the physical resource is concerned. Now, in this case, the physical resource happens to be the CPU. So what we're trying to control here is the amount of time that this resource pool and all the virtual machines that are part of this resource pool are going to have as far as the CPU is concerned. Now, you have several different options to choose from. You can choose normal, and the normal value gives you 4,000 shares, and you can choose low, obviously, which takes it down to 2,000 shares, and you can go to high, which gives you 8,000 shares. Now, as you might have noticed, 8 is double the amount of time that normal gets, and normal is double the amount of time that low gets. Now, if you still don't like these predefined shares, you can always click on custom and put in the right value or the value that you see fit for this particular resource. So I'm going to keep this at high for now. Now, the second thing we're going to talk about is the reservation. Now, think of the reservation as the minimum resources or the minimum resource access time that this resource pool needs to the physical resource in order to satisfy the requirements to run the virtual machines that are part of this resource pool. So if you had 20 virtual machines that are part of this resource pool, then they would need a minimum required access time to the CPU in order to function properly, and that's where reservation comes into place. It allows you to control that minimum time that these resources get access to. Now, we'll take a look at the expandable reservation here. Now, what the expandable reservation is, and it's useful if you have a resource pool and then you have several child resource pools under it. Because at that point, if this, for example, was a child resource pool, and this child resource pool is hungry for resources, if you have expandable check, then it is allowed to tap into the other resource pools that it can see, that it can crawl and grab any available resources that are available from these resource pools. So it's kind of handy if you have several different resource pools. It allows a resource pool to never run out of resources when it needs them. It can always find shares or reservations somewhere where it can get them and satisfy its needs. Now, the last thing we're going to take a look at as far as the CPU resources are concerned is the limit. Now, limit is the maximum resources that a resource pool can grab. At this case, we have it set to unlimited. So no matter how much it needs, and if it's available, it's going to be able to grab it. Now, if you wanted to limit that for whatever reason, if you didn't want a particular resource pool to be able to take over all the resources on a particular host, you can uncheck unlimited here, and you can use the slider up or down in order to control how much you want to set the limit at. So the limit is kind of like the maximum, and then the reservation is the minimum it needs to run this resource pool, and the shares is the amount of time or how much time you want to give these resources that are part of this resource pool access to the physical CPU in this case. So I'm going to keep this at unlimited, and we're going to take a look at memory. And memory is kind of the same thing. You have the same values here. You have low, normal, high, and custom, and you have a reservation, you have a limit, and you have unlimited, and you have the same thing with the expandable reservation. So I'm going to click on OK to create this object, and you'll notice that the accounting resource pool has been created. You can drag virtual machines onto it. Now this becomes an object within Virtual Center. So an object within Virtual Center can be set, we can set permissions against it. You can view its alarms, and we're going to talk about that in a later module. So you can treat this object as any other object in the inventory, and you can attach security and all sorts of role-based access to it. Alright, so let's go ahead and add some virtual machines to this resource pool. I'm going to take ShyVM PVS01, and I'm going to drag it here. And if I expand it, you'll notice that this is now part of the accounting resource pool. So this virtual machine is now going to adhere to all the resource permissions that we just configured as part of this resource pool. Now, if you want the virtual machine to override the resource pool, the parent resource pool that it's a member of, you can always right-click that virtual machine, and we're going to drag down to Edit Settings, and you see the Resources tab here. And at that point, you can set the CPU, memory, disk, and advanced CPU options on a per virtual machine basis. And when you set them on the virtual machine basis, they override the parent resource pool that is a member of. Now, unless there's really a need to do that, unless there's a particular virtual machine within the resource pool that you want to customize the resource access to, you shouldn't touch this, because it's easier to manage resources at the resource pool level rather than to manage resources at the individual virtual machine level. So I'm going to click on cancel. I just wanted to show you guys that you have the ability to do that as far as the CPU is concerned, the memory is concerned, and the disk. But as a matter of best practice, if you can, if there's not a compelling reason to do so, you should always do this at the resource pool level. I'm going to click on cancel to exit out of here. Alright, so let's bring up that whiteboard and take a few examples here. So you have a host that has 8 gigahertz of CPU and let's say 5 gig of RAM. Now, let's say you have 2 virtual machines here, VM1 and VM2. Their shares are both set to normal. So in this scenario, what happens is, since the shares are set to normal, the resources are going to be divvied up equally. So this virtual machine is going to get 4 gigahertz with 2.5 gig of RAM, and same thing here, 4 gigahertz with 2.5 gig of RAM for the second virtual machine as well. But what happens when you add a third virtual machine, VM3, with shares set to high? Now, as we mentioned before, shares that are set to high are going to get twice the amount of resources that those set to normal. So in this case, the calculations become as follows. VM3 is going to get 4 gigahertz of the CPU, and it's going to get 2.5 gig of RAM, whereas VM1 and VM2 are going to each get 2 gigahertz now of CPU, and they're going to get 1.25 of RAM, gig of RAM. So you see here in this example how the addition of a third virtual machine with high as the value set for shares greatly improves this virtual machine's access to the physical resources on this ESX host. Alright, let's take one more example here about resource pool and child resource pools, and then we'll wrap this up. So let's just bring a clean whiteboard here so we can better define this. This is really cool stuff. Okay, so let's say we have a parent resource pool here that has the following resources available to it. And let's say the CPU shares here are 1,000. The reservations are also 1,000. And the limit or the cap is 4,000. And let's say this is the accounting resource pool. Now, let's break this down into 2 child resource pools. Again, for the accounting department, but one of them is going to be for production, and the other one is going to be for test VMs. So we're going to call this one test, and this one prod. Now, in the production, we have for CPU shares, and I'm going to just say CPU S here. You guys are going to know what that means. It's 2,000. And for the reservation, res, we're going to make it 250. And for the limit or the cap, we're going to make it 4,000. Now on the other side, for test here, we're going to do the CPU shares at 1,000. We're going to do the reservations at 0. We're going to do the limit or the cap at 4,000. Obviously this is in megahertz here, and this is in megahertz here, megahertz here, and megahertz here. So as you can see in this example, we're clearly giving prod, the virtual machines that are in prod, the advantage over the virtual machines that are in test. So as far as CPU shares are concerned, the virtual machine prod, the accounting and the accounting department, are going to get twice the amount of access time to the physical resource that the virtual machines in test are going to get. And you're going to notice also that for reservation, for testing, we've given them 0 as far as reservation goes. So the virtual machines that are in this test resource pool don't have a reservation, clearly signaling that those aren't important virtual machines to us. When it comes time for these virtual machines to fight for resources, we don't want the test virtual machines to have anything reserved, and we want the production virtual machines to have most of the resources available to them. Now we're limiting it here. Again, we're giving it a cap of 4,000 megahertz, but we're controlling how it's being accessed in the earlier configurations. Now on the other hand, here in the production resource pool, for reservation we have 250 megahertz, so we're keeping a minimum required for these virtual machines to run properly of 250 megahertz. So clearly again here, I want to stress this, we're making sure that the production virtual machines have access to the resources when it comes time for all of these virtual machines to contend for resources. Now if there's a lot of resources, nobody has a problem. Prod is okay, test is okay. But when it comes time to fight for resources, these are the virtual machines that are going to have priority when it comes to accessing the physical resources. Probably the single most important feature of the virtual infrastructure is vMotion. This is the first feature that attracted me to this whole new technology. The ability to take a live virtual machine that's in production and move it from one host to another. I'll tell you what, I started the CDs or recording the VMware series because I was recording Citrix series before, but I started recording the VMware series because of vMotion. I was so attracted to vMotion and to this whole new technology that I decided to do this. And for those of you that have been following our CBT since VMware 3.0, you'll notice the excitement we had about vMotion. So let's go ahead and talk a little bit about it, because this is one of the most important features and probably the single most sought out feature in any virtual infrastructure. So for those of you that don't know, what is vMotion? vMotion is the ability to take a virtual machine while it's live in production and move it from one ESX host to another. Now the reason you would want to move it from one ESX host to another can be because that particular ESX host is experiencing high resource usability. So for example, the CPU on that host is being heavily utilized, or the memory. So in that case, what you can do is you can take 1, 2, 3 or more virtual machines from that ESX host and move them to another host that is not experiencing high resource usability, and thereby you load balance your resources among the hosts. And we'll talk a little later when we talk about distributed resource scheduler how DRS, for example, can load balance virtual machines among the hosts in a cluster. Now for vMotion to work, Virtual Center is obviously a requirement because vMotion is an enterprise class feature. And like we mentioned in the Virtual Center module, Virtual Center is what enables these enterprise class features. So that would be a requirement. Another good use for vMotion is if you wanted to take a host down for maintenance. You wanted to change a hard drive on it. You wanted to add more memory. Whatever the case might be, you wanted to add more CPU, whatever the case might be, and you needed to take a host down for maintenance. Maybe you wanted to patch it or upgrade it. In the past, without vMotion, you would have to take that host down completely, and there would be an interruption of service, or you would have to do this after hours. Well, with vMotion, now you can evacuate all the virtual machines that are running on a particular host, put that host in maintenance mode, and do whatever you need to. You can reboot it as many times as you need, etc., etc. There are no running virtual machines on it. You evacuated everyone, and there is no service interruption. So vMotion to administrators is a dream come true. So now let's push forward and talk a little bit about some of the errors that you can get with vMotion. What would prevent vMotion from happening from one host to another? And I've listed some of them here. For example, if it's configured if a virtual machine is configured and connected to an internal only switch. So if that virtual machine has no access to the outside world in any way, shape, or form, there's no physical adapters attached to that virtual switch, then that virtual machine wouldn't be able to migrate from one host to another. If there's a CD, DVD, or floppy configured and connected to a virtual machine, that would generate an error and you wouldn't be able to move it. If there was a CPU affinity configured or assigned on that virtual machine where the virtual CPU is assigned to a physical CPU on the host, that would prevent vMotion as well, so on and so forth. vMotion errors would prevent vMotion from taking place. However, vMotion warnings will warn you that, hey, this is not right, but it will allow you to continue to do vMotion. So for example, a warning can be generated if a virtual machine is configured but not connected to an internal only virtual switch, if it's configured but not connected to a CD-ROM, DVD, or floppy, etc., etc. Those would generate warnings, but they won't prevent the vMotion process from taking place. Now, what does the host require? What are the host requirements in order for vMotion to take place? So the source and destination ESX host would require access to all the data stores that required by the virtual machine. So let's say that virtual machine is in a particular data store, then the source ESX host and the destination ESX host would need to see all of those data stores in order for that virtual machine to transfer from one host to another and continue to service its clients and customers. Both ESX hosts would need to have similarly labeled virtual switches, and those virtual switches would need to be backed by a physical network that's a gigabit or more. Obviously, we would need a virtual switch with vMotion enabled, and we're going to talk about that when we go through the demo and how to set it up. You would need compatible CPUs, and again, you would need a gigabit Ethernet backbone. So enabling vMotion requires that each host have the same virtual switch with the same label. So it would have to be labeled the same on both ends. So if you're calling your virtual switch on ESX01 vMotion and you call it on ESX02 VM kernel, that won't work. It would have to be vMotion on both ends or vkernel on both ends before it would work. Now vMotion is obviously requires a VM kernel port, and we'll talk about that when we go through the setup steps. Now let's talk a little bit about the vMotion CPU requirements. So the number of cores, cache sizes, and hyperthreading don't matter when you're trying to do vMotion. If they don't match, then it doesn't matter. However, vMotion will not work across different CPU vendors. So it won't work between AMD and Intel, for example. It also won't work across processors with different multimedia instructions. So for example, it won't work with an ESX host that has SSE2 instructions to an ESX host that has SSE3 instructions, and so on and so forth. Now, for virtual machines that are 64-bit virtual machines, in order to migrate them, you would need to enable what's known as Virtualization Assist. Intel's version of that is called Intel VT, and AMD's version of that is called AMD-V. So in order for you to enable virtual machines that are 64-bit to migrate using vMotion, you would have to enable Virtualization Assist, and Virtualization Assist is typically enabled within the BIOS of your server. Now let's talk a little bit about NX XD-bit. Now AMD's version of that is No Execute, which is NX, and Intel's version of that is XD, which stands for Execute Disable. For the most part, they both serve the same security function, and that's to mark memory pages as data only. And that would serve to prevent, for example, malicious software exploits, and to also prevent buffer overflow attacks. Now, if you have NX XD enabled on the host, then it would need to be enabled on the destination host in order for vMotion to work properly. Now, NX XD technology is enabled by default for all guest operating systems that can use it. And this is good because you would be leveraging this technology. It would be a trade-off. You'd be trading off some compatibility, but you get security instead. Now, if you hide the NX XD flag, you increase the vMotion compatibility by permitting vMotion even if the server configurations don't match. So again, by default, NX XD is enabled, and the trade-off here is you get more security for less compatibility. Alright, so let's talk now about the vMotion process. So the VM files are all located on shared storage, and in the graphs that we have here, you'll notice that both ESX01 and ESX02 can access the same shared storage. So what does ESX01 have as far as VM1 is concerned that ESX02 does not have? And I'm going to bring up this cool animation here, and you'll notice that the RAM for VM1 is being held by ESX01. So the only difference between ESX01 and ESX02 is that ESX01 holds the RAM for VM1 because the files are both on shared storage and shared storage is accessible from both hosts. So again, vMotion is a copy of the contents of a virtual machine's physical RAM from one host to another. That's the only thing that ESX01 holds that ESX02 doesn't hold as far as that virtual machine is concerned. Once you move that, for the most part, you've moved the virtual machine, and then you just tell it to access its files from ESX02. So let's take a look at the step-by-step before we take a whiteboard and see how all of that works. So step 1, users are accessing VM1 through ESX01. vMotion is enabled, is initiated. The first step would be to create a memory bitmap to track the changes and begin copying the contents of RAM from ESX01 to ESX02. So you'll notice here that ESX02 now has a memory bitmap, and we're going to start the process of copying the memory contents from ESX01 to ESX02. Now step 2. Step 2 would be to quiesce the virtual machine and copy the contents of the memory bitmap. Now step 3 would start vMotion on ESX02 and move the user connections. So after the memory has been quiesced and you've copied the memory bitmap, then we're going to start the VM on ESX02 and move the user connections, all of that without losing any connectivity. And then you have step 4, which would remove the virtual machine from ESX01 and completely move it to ESX02. So we're going to bring up a whiteboard and talk a little bit more about how this works. So you have ESX03 here that has a virtual machine on it called v-vm01, and we want to vMotion that to ESX04. Now, in an environment, usually you will have two network connections, a network connection for vMotion, which should be on its own separate VLAN or separate network, if possible, of course. And then you have your regular network. Now, when you want to vMotion virtual machines between hosts, they always go over the vMotion network. In this scenario, ESX03 is our source host and ESX04 is our destination host. Now, obviously, they both have access to the SAN, where this virtual machine's configuration files, VMDK files, all of them reside. They both have to have access to it. They obviously have to both have access to the vMotion network and to the regular network. So when you initiate the migrate or the vMotion command from within the VI client, the first thing that happens is the memory state is copied from the source to the destination. Now, obviously, this copy or this migrate or this move occurs over the vMotion network, so as not to disturb the regular traffic over the regular network. Now, because this memory copy, this memory state copy, is happening while this virtual machine is powered on and while users are accessing this virtual machine, obvious to say that they're going to need somewhere where they can write their changes or write their commands or whatever they're doing on the server. So what happens in the meantime, while the memory state or while most of the memory state is being copied from ESX03 to ESX04, all the changes that the users are making are stored in something called a memory bitmap. This memory bitmap, of course, resides on the source host and is the last thing to be copied over to the destination before the full state of the virtual machine transfers over to the new destination host. Now, after the VM, or after most of the VM's memory state is copied over to the destination host, the virtual machine goes into a state known as the quiesced state. During this state, this is the only time where the virtual machine is not available to us. The time that the virtual machine is not available to us is extremely minimal. And during this state, this is the final stages of the cutover from ESX03 to ESX04 or from the source to the destination. And it is during this time that the vMotion process copies the memory bitmap where all the changes were happening or were stored while the memory state was being cut over. So that memory bitmap and the VM device state are the two remaining things that need to be moved over, migrated from the host or the source to the destination before the virtual machine is completely migrated to the new destination host. So during this quiesced state, the two things that are cut over or moved are the memory bitmap here, which again is where all the changes were being stored while the memory state was being moved from one host to another, and also the VM device state. being cut over from the host to the destination. Now, a question I'm sure you're already asking: what happens if a failure occurs during the vMotion process? If a failure occurs during the vMotion process, it is canceled and the virtual machine reverts back to the source host. Now, how do you monitor vMotion? Down in the task, and we'll show you this during the presentation or during the demo, the vMotion process will pause at 10% as part of the configuration identification process, and then it'll pause again at 94%, and then it'll complete. Now, the amount of time it will take to do the vMotion process will depend on the bandwidth contention and the vMotion network and the amount of RAM that is allocated to the virtual machine. All of that will determine how quickly vMotion takes place. Now, executing vMotion, we'll talk a little bit about that again during the presentation or during the demo part of this, but you can always right click on the virtual machine and click on migrate, or you can drag and drop it from one host to another. We'll talk a little bit more about that once we start doing some of this stuff. Alright, let's go ahead and launch Virtual Center and take a look at how we can do a migration using vMotion. Alright, so we've logged into Virtual Center. Now, to configure vMotion, what we're going to do is we're going to go to Hosts and Clusters, and we are going to start with ESX01. We're going to go to the Configuration tab. We're going to scroll down here to where it says Networking. So the first thing we're going to do is we're going to add a virtual switch. So let's go ahead and click on Add Networking here. And out of the 3 ports, we're going to select VM kernel because we're trying to do vMotion. We're going to click on Next. We're going to select an available physical network interface card. In this case, we're going to take VMNIC 5. We're going to name this vMotion. Now again, pay attention that whatever label you give it here, you need to give it on the other side as well in order to make sure that they communicate. We're going to give a VLAN ID of 114, and we're going to enable this port group for vMotion. So by checking this, now you're telling it that I want to use vMotion over this port group. We're going to click on Next. And here's where you get to IP it. In our case, we're going to give it 10.4.14.17 with a subnet mask of 255.255.255.0, and we're going to leave the default gateway the same. We're going to click on Finish. This will create the virtual switch on ESX01. Now I need to create another pair, so I need to create another partner for this virtual switch on ESX02. So what I'm going to do is go here to the second server. We're going to go to Configuration, and we're going to go through the same exercise. So we're going to click on Add Networking. We're going to select VM kernel again, the available physical network interface card. We're going to call this vMotion. We're going to put it in VLAN 114 again, and we are going to enable vMotion. Now, as far as an IP address, we're going to do 10.4.14.18. We're going to give it the right subnet mask. Next. Finish. Now, once you have the networking configured, as long as your virtual machines or your ESX hosts can both see the same storage where the virtual machine you're about to migrate lives, then vMotion should take place and run successfully. Again, considering all of the requirements that we talked about in the presentations are met, and nothing is going to stop vMotion from failing. So let's go ahead and do a vMotion and see if it's going to work. So I'm going to pick on ShyVM PVS01. I'm going to right click on it. And like I told you during the presentation, there's 2 ways of initiating a vMotion. You can right click on a VM and drag down here to where it says migrate, or you can always take that VM and drag it from one ESX host to another. So for example, if we go on the summary page of this VM, you'll notice that it lives on ESX01, ESX Lab 01. So if I wanted to move it to ESX Lab 02, all I would have to do is drag it from here onto the second one, and it would kickstart the wizard automatically. So the first thing you're going to be prompted with is, should I do this immediately with the available CPU resources, or do you want me to wait until optimal CPU resources are available and then move it? For the purposes of this demonstration, we're just going to go with perform with available CPU resources, and we're going to click on Next, and we're going to click on Finish. It's as simple as that. Now you'll notice down here the pause at 10%, like I mentioned in the presentation, and voila. Would you take a look at that? Now you'll notice here in the summary page of PVS01 that it is now on ESX02. But let's do this another way. This virtual machine is powered on, so let's go ahead and open its console, and we are going to go ahead and log into it. So now we're going to move this over to the side here, and we are going to do another migration and see what the interruption is as far as the user is concerned. So what I'm going to do is I'm going to right click on it again, and I'm going to click on migrate. Now when you right click on it and do a migrate, it gives you the option of what do you want to do as far as migrate, because the same migrate command will either do storage vMotion, which we're going to talk about a little later on in this module, or it will do traditional vMotion. And traditional vMotion is you're just changing the virtual machine's host from one host to another. So logically that virtual machine will live somewhere else. Now you didn't see that when we did the drag and drop, because you were automatically telling it that I just want to move this VM from host A to host B, so it didn't prompt you for what type of migration do you want to use. But when you right click on it, then it's going to tell you, hey, are you trying to do storage vMotion or are you trying to do traditional vMotion? So in this case we're trying to do traditional vMotion. I'm going to keep it at change the host. We're going to click on next, and I'm going to put this on ESX01 because it's now on ESX02, and I'm going to click on next. And again, this is where we were. Do you want to do it immediately or do you want to wait for available resources? I'm going to select finish. I'm going to click on it, and let's keep this open while we monitor the 10% pause here. And you'll notice while this is moving that I can type just fine. There is no interruption as far as this virtual machine is concerned. I can continue to work pretty much as I would on any other machine with no interruption whatsoever. And you'll notice here that it is now back on ESX Lab 01. It's just a beauty. vMotion is just amazing, and it makes everyone's life so much more easier. Let's go ahead and close this. Let me show you guys one more thing. Let's assume you wanted to see if this virtual machine is going to be vMotioned without any issues. One of the most useful things you can use here is the Maps tab. When you click on Maps, it's going to give you the vMotion map. So it's going to tell you where this virtual machine is connected to, and if both hosts can see it, and where a potential problem can be. So for example, at this point, ShyVM PVS01 can be vMotion because both of the hosts have access to the same data store where this virtual machine lives, and they both have access to the same network. So the network is configured properly on both ESX hosts in order for this virtual machine to be ported from ESX01 to ESX02. The Maps view is an extremely useful tool that you can leverage in your troubleshooting, whether it's for vMotion or anything else. But let me show you a couple of other things you can do with Maps. So let's say you wanted to do the maps as far as ESX Lab 02 is concerned. You can click on the Maps tab here, and you can manipulate it in different ways. And we talked about this earlier in different modules, but you can select different things over here to the right, and it'll give you different views as to what's connected where. You can do this on the ESX host level, or you can do this all the way up here to the data center level. If I click on the data center, I can click on Maps here. It's going to show you how everything is connected to one another, and you can always uncheck things that you don't want to see and then just apply the changes, and it'll give you different views. So this gives you how things are connected and where is a missing component. It's a very, very useful tool that you're going to use in your troubleshooting arsenal. Distributed Resource Scheduler, DRS clusters. So let's start off by talking a little bit about what is a cluster. A cluster, by definition, is an implicit aggregation of CPU and memory across different cluster nodes. What that basically means is when you create a cluster, whether that's a DRS, Distributed Resource Scheduler, or high availability, and we'll talk about that in a different module, you're able to take two or more hosts, ESX hosts, and grouping them together under a single cluster, and then managing that cluster's CPU and memory, being able to provide high availability, distributed resources, and distributed resources allow you to maintain balance of fairness across the different hosts. And I'll talk about that in a second in the next slide here. But what I wanted to say is with a cluster you can have up to 32 nodes. A cluster is an object. It's a logical object within Virtual Center. So you can treat it the same way as any other object. You can slap permissions on it, and you can manipulate it the same way. Again, a cluster allows you to group two or more hosts under a single object and take advantage of the functionality of Distributed Resource Scheduler and VMware High Availability, amongst others, as we'll see a little later on in the demonstration. Now, as far as DRS, what is DRS and what does it do? Distributed Resource Scheduler leverages vMotion technology to balance resources from a CPU and memory standpoint across multiple hosts. So what DRS will do is it will continuously monitor the cluster. Let's say you have 3 or 4 hosts in your cluster with 300 virtual machines on them. DRS's function, its responsibility, is to monitor the cluster, and if it notices that on any particular ESX host the CPU and memory utilization is high, then it will migrate certain virtual machines to other ESX hosts in the cluster and try to load balance all of the ESX hosts clusters so not one is being heavily utilized whereas another host is not being heavily utilized. So it dynamically maintains resource fairness. So without further ado, let's go ahead and log back into Virtual Center, create a cluster, add DRS to it, and talk a little bit about that. Alright, so let's go ahead and create some DRS clusters. We're going to go to Hosts and Clusters. We're going to right click on the Michigan Data Center, and we're going to drag down to where it says New Cluster. I'm going to give this cluster a name. We're going to call it Production. Now for the purposes of this example, I'm not going to talk at this point about HA. We're just going to enable a VMware DRS cluster. Click on Next. Now at this point, it allows you to select how you want DRS to behave. Do you want to configure DRS in a manual manner, a partially automated manner, or a fully automated manner? Now what that means here is if you configure DRS in a manual manner, what will happen is DRS will recommend which virtual machines need to move to which hosts, but it won't actually move the hosts, move the virtual machines. It will simply recommend what it thinks needs to happen. So it gives you a scenario. Partially automated means that when virtual machines power on for the first time, DRS will automatically initially place them where it thinks they should go. So it will select the best ESX host at power on in an initial placement scenario, and the ongoing maintenance Virtual Center will only recommend but will not move the virtual machines from host to host. And then you have fully automated. Fully automated is really great. I use it in all the environments. Unless there's a specific reason why you don't want to use fully automated, it should be always used. Fully automated makes your life easier, allows DRS to control the placement of virtual machines from the time they get powered on and an ongoing maintenance. It allows you to maintain the dynamic load balancing of all your ESX hosts resources. So it will recommend and it will move the virtual machine among hosts onto the best ESX host that it sees fit based on the circumstance at that point in time, and it will continue to move those virtual machines and maintain load balancing. Now, as far as the migration threshold is concerned here, you will have to take that up or down a notch based on how often you want these migrations to happen. So at this point, at the level that I have it here, it applies to priority 1, priority 2, and priority 3 recommendations based on what Virtual Center dishes out. So if you want to make it more aggressive, which means you want to do more migrations, then it will apply priority 1, 2, 3, 4, etc. So you can move this slider up or down, and that controls the frequency of how often DRS will move virtual machines. And you'll have to go through some of the priorities to figure out, well, you know, if there's this amount of CPU utilization on a virtual machine, I don't necessarily want to move it. So being very aggressive isn't necessarily the best thing to do. Sometimes if you are very conservative, that is a better option, because when you're very conservative, that means it will only move virtual machines when it is absolutely necessary. For my case, I always like to stay somewhere in the middle. So in my case, this would be a good threshold as far as migration is concerned. More towards the conservative side, that way it doesn't constantly move and take off all of the bandwidth off of the network. Unless that virtual machine is really in need of moving from host to host, don't really move it, is kind of what I'm telling it here. So we're going to click on Next. Distributed power management is another great feature in the DRS cluster. What distributed power management allows you to do is, let's say every night you have 10 or 12 ESX hosts with a lot of virtual machines running on them, but you want to conserve on power. So what DPM will do is, because at night you don't have a lot of users, so there's not a lot of number crunching going on, the systems aren't being that heavily utilized, What DPM will do is it will evacuate virtual machines and consolidate them on the least amount of ESX hosts necessary to run these virtual machines, and then it will power down the remaining hosts, the remaining ESX hosts. Then what happens is, at an interval that you specify, it will bring those virtual machines back up. So, for example, you can configure it here to either be off, which is the default setting, or be manual, which means it will recommend that these virtual machines be migrated or evacuated from a certain host, and that host be powered down or suspended for that matter, or automated, where it will evacuate the virtual machines when it sees necessary, power down the ESX host, and then power back up ESX host when it needs them. So with distributed power management, if the systems aren't being utilized, if the virtual machine activity isn't there, what happens is it will consolidate them on a number of ESX hosts, power down the remaining, save on power and cooling and all that good stuff. Once those virtual machines start to get used again, start to get heavily utilized again, distributed power management will start powering ESX hosts back on in order to maintain and load balance again using distributed resource scheduler. So DRS and DPM go hand in hand, and they leverage Wacom LAN, IPMI, and ILO technology in order to control the power on and power off of the ESX host. And you'll notice that the same as with DRS, where we had the threshold, you have the DPM threshold again for how often do you want this to happen. What priority level do you want this to happen on? Do you want me to be very aggressive with these VMs and with powering down and powering up these ESX hosts, or do you want me to be conservative? In my case, I'm going to again choose it's off by default, but if I had it on, I would choose very conservative. Now keep in mind, if you wanted to use this feature, you would have to configure the Wacom LAN, the IPMI, and the ILO prior to actually enabling this cluster. So I'm going to keep this off. We're going to click on next. Now this next feature here is really cool, and it's called Enhanced vMotion Compatibility, otherwise known as EVC. Now what you can do with EVC is, like I mentioned when we were talking about vMotion, vMotion has certain limitations. You can't vMotion across CPUs from the same manufacturer but with different families, for example, so you can't jump around. So what EVC allows you to do is it allows you to standardize within the cluster on an acceptable baseline. So what that means is, let's assume you have ESX hosts that are all Intel in this cluster that we're creating. But every one of those Intel processors that are in the hosts are of different families and different generations. Typically, that would pose a problem for vMotion because it wouldn't vMotion properly. What EVC will do is it will present a baseline to the virtual machines with the minimum features available with the CPU host. So it will take all the CPUs across all the hosts and it will select what features they all have in common. So it will take the lowest common denominator of all of the CPUs, it will present that to the virtual machine. So at that point, the virtual machines see all the same features that are being presented from the host, and thereby allowing vMotion to take place. This is one way of enabling vMotion across hosts that are of different CPU families. Now, there are restrictions to EVC. So for example, for EVC to function, you can't mix Intel and AMD, so they have to be the same manufacturer. You would need ESX 3.5 update 2 or later in order to use EVC. As far as the Intel processors are concerned, you would need to use Intel with Core 2 micro chipsets and higher, and AMD second generation Opteron CPUs and higher. Obviously, you'd have to be connected to Virtual Center, and you would need to have a Virtualization Assist, AMD V, and Intel VT enabled as well. And you would need to have the NX and XD, as we talked about during the vMotion, those would have to be enabled as well. So now, if you wanted to take advantage of EVC, by default, it's disabled. You can enable it if you have if the hosts that are in your clusters are AMD, or if the hosts that are in your cluster are Intel, then you can enable it, and then you can select the baseline. What is the minimum common denominator that you want to use across the board for all of these ESX hosts? So it gives you several different baselines here that you can choose from to select which baseline you want to use for this particular cluster. In this case, you can use, for example, the Intel Xeon Core 2. I won't enable this because the hosts in my cluster are of the same generation, so I really don't have a use for it. But if you're going to add clusters of different generations, then this is what you would need to do in order to make sure that vMotion happens across the cluster. So I'm going to keep this disabled. We're going to click on next. And now we get to the point where it wants to control or wants to understand from a policy standpoint where you want the virtual machine swap files to be stored. You have two options. You can store the virtual machine swap files in the same directory as the virtual machine, or you can store the virtual machine swap files on a different data store. Now, the reason you would want to store it on a different data store is depending on your environment and the type of performance you're anticipate on getting or you want to get. If you store the swap file, for example, on lower performing disks or on cheaper disks, you can do that, or you can select it, or you can choose to place the VM swap files on higher performing and more expensive disk. For the purposes of this demonstration, we're going to keep the swap file directly with the virtual machine in the same data store. Now keep in mind, if you move the swap file on a different data store than the virtual machine, then vMotion will take longer to happen. So I just wanted to throw that out there. So I'm going to keep this at default, and I'm going to click on next. You can review what we were going to do here. We're going to click on finish, and there you go. It just created the production cluster. Now what I'm going to do is I'm going to take ESX01 and I'm going to drag and drop it under this cluster. Now when you're trying to move the ESX host that has virtual machine underneath, you have two options. It'll either move all of the host's virtual machines under the root of that cluster, or it allows you the option of starting to create resource pools and moving those virtual machines under those particular resource pools. For now, I'm just going to leave it under the root. And I'm giving me a warning because I have a VAB, it will destroy the VAB. So in this case, I'm fine. We're going to click on next. And we're going to click on finish. And voila, it moved the first ESX host under it. Now what I'm going to do is I'm going to move ESX02 under that cluster as well. Now you'll notice ESX02 already has resource pools. So what happens in this case is it will also import the ESX resource pools under the cluster. Now for this case, because I have resource pools under this ESX host, I'm going to select the second option because that allows me to maintain the resource pool structure that I'm importing with this ESX host. So I'm going to keep it as is. We're going to click on next, and you can give it a name here. I'm going to keep this default name. I can change it later, or actually let's go ahead and change it now. Let's just call it test for now. We're going to click on finish, and voila, bada bing bada boom. Let's go ahead and expand this cluster, and you'll notice that ESX02, you'll notice I've imported my resource pools that were under ESX02 are now under the test resource pool. And both ESX hosts are now in this production cluster. Now if I right click on this production cluster and I want to edit the settings of this particular cluster, I can come down here to edit settings. This allows me the opportunity here to enable HA if I wanted to. I can always disable DRS again, and it gives you, again, we go through the same screens here. You can configure manual, partially automated, fully automated. Let's talk a little bit about rules. So what are rules? So in a lot of cases, you have multiple virtual machines that you don't want to be present on the same host at the same time. You always want these virtual machines to be on different hosts for whatever reason. Maybe that you're trying to load balance them and you don't want them to exist on the same host, so if that host fails, you always have a different node somewhere else. That could be one of the issues. You can click on add here. You can give it a name. So you can say web separated, for example, in order to separate web servers. And here is where you can select what type of rule you want to do. You have two. You can either keep virtual machines together, or you can separate virtual machines. If you keep virtual machines together, that means if it's vMotioning one, it's going to take the other one with it. That means you're telling DRS that these two virtual machines have to exist on the same host at all times. Or if you select the second rule here, then what you're telling it is these virtual machines need to always be separated on different ESX hosts. Now keep in mind, if you have two ESX hosts in a cluster, and you have rules which say I need to separate these VMs, then if you go to put a virtual, or if you go to put an ESX host into maintenance mode, and that rule exists, that host will never go into maintenance mode until you either disable this rule or power off one of the virtual machines in order to allow that host to completely go into maintenance mode. Because when you put it into maintenance mode, it's going to try to evacuate all the virtual machines. When it tries to evacuate the virtual machines, it's going to have a conflict with this rule because it can't take those two virtual machines and place them on the same host. So make sure you take that into consideration. Now once you select the type of rule you want, you can always click on add here, select the virtual machine. It's going to give you a list of all the virtual machines that are available. You can select them. So let's do these two for example. And you can always click all obviously, or none. Next, OK, and voila. Now you've created this rule. So again, if you wanted to place this ESX host into maintenance mode, you would have to come back in here, disable this rule in order to allow that ESX host to go into maintenance mode, and then when you're done with all the maintenance you need, you can always come back here and enable it. All right, let's move on to virtual machine options. And this is really cool because here now you are able to select the automation level based on virtual machine. So for example, if I select MPCTX Con 05, I get a drop down menu here that says the default is fully automated, obviously, and then you could go partially automated, manual, or disabled. If you don't want this virtual machine to participate in any type of a DRS, you can disable it, or you can override the overall cluster settings. When we select it partially or fully or manual, you can come here and do it on an individual virtual machine basis and override the cluster level. For the purpose of this example, I'm just going to leave this at default. And then I'm going to move on to power management, which we also talked about. But again, if you wanted to enable it after you've configured your IPMI and your ILO and your Wacom LAN, you can come in here and select manual or automatic as far as DPM is concerned. You can go into host options, and then you can select a particular host. You can either go with the default, which is disabled, or again, you could do manual or automatic for a particular host. And then finally, you have the VMware EVC, which we also talked about. And over here it's disabled, but you can always click on change and change it over here. And then you have the swap file, which we also talked about. So I'm going to click on OK to exit out of here. Alright, so I've switched Virtual Center servers here. What I'm going to do is let's click on the lab cluster. And you'll notice here that if you go to the DRS tab underneath it, you'll be able to take a look at the Virtual Center recommendations as far as all the virtual machines in the cluster are concerned. So at this point, I don't have any recommendations listed here. If I click on Run DRS up here to the right, it's still not going to give me anything because I don't have enough going on in my cluster to recommend virtual machines be moved from one host to another. But if I had, and you had your migration automation set to manual, then you can come into the DRS tab here and take a look at what Virtual Center is recommending in order to improve the performance of the virtual machine and relieve the ESX host that it's running on. Now if you wanted to manage the cluster settings, again, an easy way of doing it from within here is just click on edit and it brings you back to the cluster settings. Click on cancel here. So just a little tip here onto where you can go to take a look at some of these recommendations that DRS would make, because we mentioned that a few times. Now we've talked about storage vMotion all through this course, but let's finally officially talk about storage vMotion. Storage vMotion is another fantastic feature that vSphere offers. Now if you guys were excited about regular vMotion, storage vMotion is even more fun. Storage vMotion allows you to take a live running virtual machine and migrate it from one data store to another. It is just magic. So if you thought moving the virtual machines from one host to another was magic 2 years ago or 3 years ago, then storage vMotion is the new magic, because now you can not only just move the VM from host to host, you can move the VM, also the VM's files, from data store to data store. So if you're going through an upgrade, or if you wanted to take down a particular storage and you wanted to evacuate virtual machines off of it, now you can take that down without impacting production. Storage vMotion is just fantastic. Let's take a look at some of the benefits of storage vMotion. So storage vMotion offers great flexibility as far as the design, configuration, and management of storage, because what it allows you to do, and I had this as the last bullet point item, but we're going to talk about it, is it allows you to do tiered storage. So let's say you bring up a bunch of virtual machines, 200-300 virtual machines, and 2-3 months down the line you notice that, well, these virtual machines aren't performing very well, and currently they're on tier 3 storage, and I want to bump them up to tier 1 storage. Well, you can take these virtual machines, do a storage vMotion from tier 3 to tier 1, which is more expensive disk, and allow these virtual machines to perform better because now they're on faster disk. The same thing if you add a virtual machine and all of a sudden, well, you're noticing that this virtual machine can probably exist on tier 2 storage and it will perform just as well. What you can do is you can take storage vMotion, take that virtual machine down to tier 2 storage, and then if it doesn't work properly, take it up, or if it's still performing good, you can take it down a notch. So it allows you to do dynamic load balancing. Well, it's not so much dynamic, there's still a manual process in it, but since I said dynamic, VMware is also working on a module the same as with Distributed Resource Scheduler, where it uses vMotion to dynamically load balance the virtual machines across the hosts. There's going to be a new module that allows you to dynamically load balance virtual machines from an I/O perspective across the different LUNs that you have. So if it sees that it's hammering a particular LUN, it will take a virtual machine and do a storage vMotion automatically on it and move it to a LUN that's not getting so much hammered. So storage vMotion right now doesn't have that feature because it's manual. You have to load balance it manual, but that's coming, so I wanted to throw that out there. Now, obviously, if you're coming off of older ESX environments where you've provisioned LUNs that are smaller in size, for example, I've walked into a lot of environments where the LUNs were 250 gig or 300 gig or 500 gig, and you wanted to go to a terabyte or 2 terabyte worth of data store LUNs, for example, and an easy migration would be to present that new data store and do a storage vMotion of all your files off of the old one, and then just start getting rid of the older LUNs. Again, it's a very non-intrusive, you don't have to bring anything down. Obviously, best practice will dictate that you do this off hours so that the I/O doesn't take a hit, but there's no reason why you can't do this one at a time, or if you want to just chop off or take them down in tasks, you can always do that during production hours as well. Now, storage vMotion can be done over local, iSCSI, NFS, Fiber Channel, etc. It doesn't really care as far as the type of disk is concerned. Storage vMotion requirements. So you can only do up to 4 concurrent storage vMotion migrations at the same time. You can only have 4 going on at the same time. If you wanted to do host and storage vMotion at the same time, you can only do that if the virtual machine is powered down. Now, that being said, I want to open a bracket here. There's no reason why you can't do the regular vMotion first, move the host from ESX1 to ESX2, and then as a second step, do storage vMotion, which will take the files and move them from host A to host B. What it won't allow you to do, and I'll go back into the GUI and I'll show you that, is it won't allow you to do them at the same time, because you have an option of either to migrate the host, migrate the storage, or do them both. So that third option you won't be able to do unless the virtual machine is powered down. Virtual machines that have snapshots cannot be migrated using storage vMotion. Now, you also have to understand that when you're doing a storage vMotion, the source and destination data stores must be visible to the host running the virtual machine. So the host that's going to initiate the storage vMotion has to be able to see where the virtual machine is currently stored, obviously, but it also has to be able to see where you're trying to move that virtual machine to. Because keep in mind, this is storage vMotion, so once the files move, that host still has to be able to see where you moved the files to in order to maintain that virtual machine in a running state. It goes without saying that the destination data store must have enough space in order to accommodate the virtual machine, and the host running the VM must have enough memory to hold a second copy of the VM being relocated until that relocation is done. Now let's try and do an actual storage vMotion. So I'm going to pick on VMFS01. We're going to right click on it, and we are going to go ahead and open the console. So the virtual machine is actually powered on. Now remember, this virtual machine had snapshots. So if I click on VM here and drag down to snapshot, you'll notice that in the snapshot manager, I have several snapshots. And if you're trying to do a storage vMotion while you have snapshots and the virtual machine is powered on, that's not supported. If you want to move it with snapshots, you have to power the virtual machine off. So what I'm going to do for the purposes of this example is I'm actually going to delete these snapshots, and we're going to click on close. And now what we're going to do is we're going to browse on ESX01. Let's browse the data store where the FS01 files are at. So it's in MPCTX ESX01 on storage 2, and we want to move it to storage 1. So what I'm going to do is I'm actually going to right click on it, drag down to where it says migrate. Now keep in mind, the first option here is change host, which is a traditional vMotion. Now you'll notice it's grayed out. That's because I haven't configured my networking to support vMotion. The second option would be to change the data store, which is storage vMotion we're going to do now. And the third option would be to change both the data store and the host, so it's vMotion and storage vMotion at the same time. So I'm actually going to click on next to continue. I'm going to keep this at the default, and I'm going to select storage 1 here. So you'll notice we have both. I'm going to select storage 1. Now here you have the opportunity of changing the virtual disk type. Again, storage vMotion is one of those ways where you can change the virtual disk type from thin provisioning or thick provisioning, etc. We talked a lot about that in the thin provisioning module. The purpose of this example, I'm going to keep it at default. We're going to click on next and finish. Now you'll notice here I'm going to bring this up, and I'm also going to bring up the console of the virtual machine. Hopefully this is not too much, it's not crowding the screen too much for you guys. And you'll notice down here in the progress bar that this virtual machine is actually being moved. Let's go ahead and log into it. Awesome. Now let's take a look and see if we can refresh this data store here. And voila, VMFS01 has been storage vMotion while the virtual machine is powered on. Now let's go into storage 1 and take a look at that. There it is. It moved all of the virtual machine files. Now you can do this from local storage to local storage, as I did. You can do it from local storage to SAN, from SAN to SAN, etc., etc. Storage vMotion is truly a fantastic little tool that can come in handy in a lot of different environments. Let's talk about thin provisioning. What is it and why is it so important with vSphere 4? Thin provisioning allows you to allocate space without actually committing it to a host. So in other words, it allows you to not over provision storage. What we do today is if someone walks up to us and says, I need a LUN that's 500 gig in size, you give them a 500 gig LUN size. That 500 gig is committed automatically to disk, so you take it out of your available storage. Now what happens is you revisit this space 3 or 4 months later, and you'll notice that out of that 500 gig, only 100 gig has actually been used. And over time, you'll notice that there's a lot of disk or storage that you've committed to host that hasn't been used. Thin provisioning allows you to get away from that. So if someone walks up to you and says, I need a 500 gig LUN, you can provision a 500 gig LUN but not commit that storage right away. So as they start using storage, that storage gets committed. So let's say you give them a 500 gig logical LUN and they only use 100 gig, then technically as far as your storage is concerned, you're only using 100 gig and that 400 gig is left as a buffer. Now if the system needs access to this 400 gig, the system will automatically and dynamically get this 400 gig. So you got to be careful here. While you're not provisioning all the storage up front, you want to make sure that when that host actually wants or needs access to that storage, that storage is available to the host. Now, thin provisioning isn't new to ESX. It was available with ESX 3.5. The difference is with ESX 4 or vSphere now, it is official. You have access to it. You can do it via a GUI. It's no longer kind of in an experimental mode. But you had this through a command line using ESX 3.5. So traditionally, the way you did thin provisioning was at the storage array level. So if the type of SAN that you've deployed in your enterprise didn't support thin provisioning, there was no way for you to do thin provisioning. What vSphere introduces, or the thin provisioning features of vSphere, allow you to do thin provisioning at the ESX level rather than do it at the storage array level. Now if we open a parentheses here, you're probably what's probably going through your mind is, well, which one should I use if my storage supports it? Should I use it at the ESX level, or should I use it at the storage array level, or should I do a combination of both? The answer from my perspective is use it at the storage array level. Let the SAN administrator worry about storage, provisioning storage, making sure he or she has enough storage when these hosts want access to it. If you do it at the vSphere level, at the ESX level, then you have to make sure that you never run out of disk space or storage as far as your data stores are concerned, otherwise you're going to crash them. So you constantly need to monitor that. You constantly need to go back and worry about dealing with the storage administrator to make sure you always have the storage you need. So from my perspective, as a best practice, I would leave thin provisioning at the array level if your array supports it. Now, if your array doesn't support it, you obviously want to use and take advantage of the features introduced with thin provisioning, because it allows you to save on committing to storage today and allows you to provision as much storage as your hosts need it, and then gives you that period of time to feel if they're using the storage. If you notice that you gave them 500 gig and all of a sudden 2 months later they're at 250, 300, then you can go back to management and justify it and tell them, look, we are using this space, we're using thin provisioning, so we're starting to use this space, I need to purchase more storage. So it allows you to postpone the purchase of storage until you absolutely necessarily need it. Now, the way you do thin provisioning at the vSphere level is you do it via virtual disks. You take these virtual disks and you provision them either as thin or thick. As we're going to see in the next slide here, there's 3 different ways you can provision virtual disks with vSphere 4. But before we move on, I just want to make another note and let you guys know, while I don't want to get into a discussion on storage because this will bring up a lot of arguments and people have different viewpoints on the subject. But if you use thin provisioning on an array that's supported, on a storage array that supports thin provisioning, and if the storage array also supports wide striping, which means it's going to take different RAID groups, RAID 5, RAID 1 plus 0, the different types of RAID groups that you have on this storage, and it's going to write across all of them. So that means there's going to be more spindles on the back end, more hard disks that it's writing to, thereby it's also going to improve performance. So if you have the ability, if your storage array can do thin provisioning plus wide striping, you're also going to see a performance increase by using this in addition to the storage savings that you're going to get out of it. And I use the term savings here very loosely. You're not really saving, you're just postponing the commitment of storage that you need to do. So instead of giving someone 500 gig that you're not sure if they're going to use, you're logically giving them that 500 gig, and as they start using it on the back end, you just fill in the gaps as you need them. So now let's take a look at the types of disks that come with vSphere as far as thin provisioning is concerned. The first type of disk is a thin disk. What a thin disk is, if you provision a virtual disk in a thin mode and you're looking at it from the data store perspective, and you gave that thin disk it's a 500 gig thin disk, but you're only using 100 gig. So in that case, as far as at the data store level, you're going to see that VMDK at 100 gig. As the virtual machine starts to use that disk, as it starts to generate I/O, the VM kernel will automatically expand that VMDK as the storage gets filled. So I'm going to show you an illustration. Actually, let's move on to the second slide here. You'll notice that the thin disk, as far as the data store is concerned, if you've provisioned a 100 gig virtual disk, for example, and you're only using 20 gig, it's only going to see 20 gigs, or only using 20 gig as far as that's concerned. Now here's the problem. That host expects to see 100 gig. So as it starts to use it, if that 80 gig isn't available to it, you're going to have a problem. You're going to crash it. So you want to make sure that if you're doing thin provisioning at the ESX or the vSphere level, that you monitor your storage, and as these virtual machines need access to the storage, you want to make sure that storage is available. Let's take a look at the second type of disk, thick. Let's go back to the definition here. Thick, otherwise known as zero thick, is intended so that you can do thin provisioning at the array level rather than doing it at the vSphere level. So what you get with this type of disk, and let's take a look at the example again. Let's say you provision 100 gig VMDK. As far as the data store is concerned, as far as ESX and vSphere are concerned, this is 100 gig VMDK. It's going to take up 100 gig. But what you're doing, you're telling the array that I'm only using 20 gig out of the 100 gig. So you're not zeroing the space that you're not using. So what that tells the array is, hey, I have 80 gig here of space that's not zeroed, so that means there's no data on this 80 gig. Go ahead and not count that as space that's being used. So at the array level now, it sees 20 gig of used space, and it can take that 80 gig and treat it as unused. Now the difference, if you look to the right here, with the eager zero thick, let's go back to the definition. What eager zero thick will do is it will take the entire VMDK and it will zero out everything, the free space and the used space. So as far as the array is concerned, all the bytes on this disk are being used. So the array wouldn't be able to tell at that point if there's any free space available, and you wouldn't be able to do any type of thin provisioning either at the ESX vSphere level or at the array level. With eager 0 thick, the entire VMDK is treated as being used as full. So these are the three types of disks that you get with vSphere that allow you to do the different things. By default, the thick or the 0 thick is what everything gets created as. Except if you're using NAS or NFS, then automatically your disks get created as thin. But everything else, by default, you're going to get thick as the default virtual disk type. Alright, so let's jump into Virtual Center and take a look at how we can create thin, thick disks and how it works. Alright, so once we're in the Virtual Center here, what we're going to do is we're going to go up to Hosts and Clusters. And we have a VM that's pre-set up. So what we're going to do is we're going to right click on it and try to add a virtual disk just to give you an example of how it would work to set up thin or eager 0 thick for that matter in this exercise. So we're going to click on Edit Settings. We're going to click on Add here. We're going to select hard drive or hard disk. Create the default. Let's make this 5 gig just for giggles. Now you'll notice there's two checkboxes or radio buttons here. If you select the first one, which is allocate and commit space on demand thin provisioning, what you're telling it to do is allow thin provisioning at the virtual disk level. This means you're doing vSphere thin provisioning at this point. Now if your storage array supports thin provisioning, you wouldn't have to do anything because the default disk type is thick, 0 thick that is. Keep in mind, I'm using these terms here and I need you guys to keep up. 0 thick is different than eager 0 thick. Eager 0 thick is when it consumes and zeroes out the entire space. So by default, if your array supports it, you don't have to do anything at this point. Click Next and it's going to create your virtual disk in a format that is thin provisioning friendly. Now, if your array doesn't have it and you want to do thin provisioning at the ESX or vSphere level, then you would select this first option. Now, you'll notice that if you select the first option, the second option, which is to support clustering features such as fault tolerance or Microsoft clustering for that matter, automatically gets disabled. Which means if the purpose of this virtual machine is going to be in a cluster, fault tolerance or Microsoft clustering, you would have to select the second option. Now by selecting the second option, you're automatically making your virtual disk type eager 0 thick, which means it's going to consume and zero out the entire space on that virtual disk. Alright, so for the purposes of this example, I'm actually going to use allocate and commit space on demand thin provisioning at the vSphere level because I want to show you something after this. So we're just going to click on Next here to create it, and we're going to click on OK. Let's assume you wanted to change the virtual disk type. There's several ways of changing the virtual disk type. One of the easiest ways of doing it is to use storage vMotion. Now the way you do that, you're going to right click on that virtual machine. We're going to drag down here to migrate. The second option here is change data store. Now you'll notice that there's several new features for migrate. Change host is the default vMotion where it's going to take the virtual machine and logically move it between hosts. For the purpose of this example, we're going to select the second option, which means it's going to take the virtual disk files and migrate them. So we're going to click on Next. We get to this screen that allows you to change the virtual disk format. Now you can keep the disk the way it is, the same format as source. This is when you're moving, obviously, storage. You can do thin provisioning at this point, or you can do thick format. Now keep in mind, when we say thick format here, we don't mean eager 0 thick. It's a little confusing, I know, and I don't understand why VMware did this, but I need you guys to pay attention that thick here means 0 thick, not eager 0 thick. So if you were wondering, well, how do I go from thin to 0 thick or from 0 thick to thin, this is one way of doing that using storage vMotion to change the disk type. Now I know it's kind of a convoluted way of doing it because you might not want to move storage. You might want to stay on the same storage. You just want to change the disk type. For the moment, this is this is one of the ways that you can do this. Now we're going to click on cancel here. And the other question that I get asked a lot of times is, how do I go from thin to eager 0 thick? How do I consume all the space on that virtual disk? Well, Here's a way of doing it. You can do it either via command line, or if you wanted to do it via the GUI, let's take a look at how we would be able to do that. We're going to go to the actual host here, and we're going to browse the data store. We're going to select the virtual machine directory. And you're going to notice, the first thing you're going to notice here is that the virtual disk that we created, which was thin provisioned, is consuming 0 space on that storage. Because with thin provisioning, again, the only thing you're going to see is that space that's being used. Since this disk is brand new and we haven't used it for anything, there's no data on it, it's going to show up as 0. But the capacity of that disk was 5 gig, if you guys recall from when we created it. Now let's assume for whatever reason you wanted to change the disk type from thin to eager 0 thick, which means you're going to take up the entire space, the entire capacity of the virtual disk. Well, one of the ways you can do that is you can right click on this and you can do an inflate. When you do an inflate, what it's going to do is it's going to zero out all of the capacity that is available to this VMDK. And in a few seconds here, you're going to notice that the disk size has changed from 0 to 5 gig, which was what we assigned it. Alright, and as you guys are going to notice here, now that the conversion or the inflation has been complete, the new size of this VMDK is now 5 gig, which is the size that we allocated to it when we were creating this virtual disk. Alright, now another way of using the inflate via a command line like the remote CLI or the VMA, if you're using the appliance to issue commands, I'm going to bring up a slide and I'm going to show you the different commands that you can run either from a command line directly on the service console if you're using ESX, or if you're using ESXi or even ESX, but with remote CLI or the VMA, you would be able to issue commands directly and inflate this. So again, in order for you to go from thin to thick, 0 thick, or from 0 thick to thin, you'd be able to use storage vMotion. If you wanted to go from thin to eager 0 thick, you'd be able to do that through browsing the data store, initiating the inflate command, or running a remote CLI or command line interface command directly, issuing the command that way. Alright, so to convert to eager 0 disk, if you're on the service console of the ESX server, you would initiate the following command. And if you're doing it from remote CLI or the VMA, you would issue the following command to do so. So this brings us to the end of this lesson. I hope it's been informative for you, and I'd like to thank you for viewing.